Good morning to all. In this video, we are going to see load test and single phase transformer. In this experiment, we are going to see how to find out efficiency and voltage regulation of a single phase transformer. So now first we'll try to understand the circuit diagram for performing this test. And we know that the objective of the experiment is to perform load test on single phase transformer in order to find out efficiency and voltage regulation. And we know that transformer is a device which will transform AC electrical energy from one circuit to other circuit. And we all know that transformer having two windings, right? Primary winding and secondary winding. You can see this is what primary winding, this is what secondary winding. And we know primary winding generally connected to the input supply side, whereas secondary winding generally connected to the electrical load side. So the our objective is to find out the efficiency of a transformer, right? And we know that the efficiency is nothing but output divided by input. If you look at the transformer operation, we know both input and outputs are electrical power. So if I want to know the efficiency of transformer, I need to measure output power as well as input power. And we all know that if you want to measure the power practically, we want to use a meter called watt meter. So you can look at here, I have kept two watt meters, you see. So this watt meter is actually connected to primary side, so which helps to measure the input power, whereas this watt meter connected to the secondary side. This is secondary winding, right? So this watt meter helps to measure the output power. So now by dividing this output power by input power, I can able to figure out the efficiency, right? And then the other objective is to find out voltage regulation of a transformer. See, the voltage regulation is nothing but it is changes in voltage. And we all know that in a circuit where if you connecting all the apparatus in parallel, we expect that the voltage across all the components must be same. But practically sometime it won't be there, which means if you look at over here, so secondary side I have connected here load, I am using more specifically resistive load here. So I expect whatever the voltage I am getting on this winding should be equal to voltage across the load, if I am speaking theoretically, but it won't be there due to various reasons. Now in order to figure out what is the voltage deviation between these two, we are coming up with the terminology called voltage regulation. So voltage regulation is nothing but the deviation of voltage from no load to when the circuits are added with the loads. So I would say theoretically now voltage regulation is something but voltage at no load, in sense when I keep all the loads are zero, I will measure what is the voltage across this point, minus I am adding some voltage, I am again measuring what is the voltage across this point, divided by the voltage at no load into 100 will give voltage regulation. So now if you want to measure the voltage regulation, I want to get the voltage across the load. So for that I am going to use the meter called voltmeter. And we all know that voltmeter must be connected parallel to the component where we want to measure the voltage. So that's why you see this voltmeter is connected across the secondary winding. So this is what the secondary side. So I repeat, we have connected wattmeter to measure output power, voltmeter to measure the voltage across the load, and then additionally also kept a meter over here to measure how much current is taken by the load. Okay, and we know that ammeter must be connected in series, that is why it is connected in series with the load as well as secondary winding. So this is what the secondary side components. Now let's coming back to first primary side. You see in primary side, as I said already, we are having wattmeter which helps to measure input power, and then we are also having auto transformer, and we know that the auto transformer helps to regulate the voltage, right? So in order to give voltage slowly to the primary winding, we are using this auto transformer. Okay, it is just like a productive device. And then followed by you having fuse, then we are having switch which is double pole single throw switch, then we are giving input 230 volt 50 hertz AC supply, right? And then in order to measure the input voltage, we are also keeping voltmeter here which are connected parallel to the primary winding. So this is what the purpose of each component in the circuit. Now let us try to see how can we make this practical connection. Okay, now let's see how can we make a practical connection. So this is what transformer. So this is a primary side, the other is a secondary side. Now let's first try to make primary side connection. So in primary side connection, we know that we need an auto transformer. This is what auto transformer. And then to measure the voltage, I am using voltmeter. Then to measure the primary side power, that is input power, I am using wattmeter. Now let's try to see how can we make primary side circuit connection. So now you can see this is what auto transformer, right? Auto transformer phase now needs to be connected to voltmeter common terminal. Okay, so you see in auto transformer there are two terminals, phase and neutral. So I'm going to connect now auto transformer phase to voltmeter common terminal. So I connected to voltmeter common terminal, right? And then next voltmeter 300 volt terminal must be connected to auto transformer common terminal. Now you see voltmeter 300 volts. So you see there are three ranges, 150, 300 and 75. So we are giving input as single phase AC voltage. For single phase, voltage level is around 230 to 240. So I am choosing now 300 volt range. So now this 300 volt range I am connecting to auto transformer neutral terminal. So now what we did, we connected voltmeter across the auto transformer. So phase is to common and this neutral point to 300 volt terminal. So we are connected across. Okay. Now this is over, and you see auto transformer input is connected to supply. So you see auto transformer, this is what input which I connected to the supply side already. Done. Now we'll try to see how to connect next wattmeter. Now voltmeter common must be connected to wattmeter M terminal. So now I'm taking this yellow color wire. This is going to be connected to ammeter M terminal. So we are connected to ammeter M terminal, and then ammeter L terminal must be connected to primary winding P1 terminal. So now ammeter L, this yellow color wire, ammeter L is connected to primary side P1 terminal, right? And then now I need to connect wattmeter M and V internally. So let's take from M, and then if I see V, there are three ranges, so 150, 300 and 75. Depending upon my input level, I need to choose. See, for us single phase transformer, we need of 230 to 240 volt around. So I am choosing 300 volt range. So I have connected M to 300 volt range, right? And then wattmeter common must be connected to that is primary winding P2 terminal, also either voltmeter 300 volt terminal or auto transformer common terminal. Okay, so let's do it. Let's connect now common terminal, this blue color wire, which is connected to transformer primary winding P2 terminal, right? So you have connected this C to P2. Now again this must be connected this side also, right? So this I am going to connect with the voltmeter 300, and we know already voltmeter 300 we have connected to auto transformer common. This will complete the primary side connection. So now for this red color wire, which is wattmeter common, is connected to voltmeter 300 volt point. So this is what primary side connection. The secondary side connection. In secondary side, we are going to use one voltmeter and then one wattmeter and then one ammeter and then one electrical load, resistive load. And we have seen that already. The voltmeter helps to measure the secondary side voltage, wattmeter helps to measure the output power, ammeter helps to measure the load current. Okay, let's see how to make this connection. So this is what transformer secondary side, it having two terminal, S1 as well as S2. Now first I need to connect S1 to the voltmeter common terminal. Okay, so I am going to connect S1 to voltmeter common terminal. So this blue color wire. So S1 I am connecting to voltmeter common. right? So this we are connected to voltmeter common terminal. Okay, we are connected to voltmeter common terminal, right? And then voltmeter voltage terminal must be connected to S2. So again, if you look here, we are having two ranges, right? 150 and 300 volt. So this is actually a step down transformer. We are stepping down the voltage from higher level to lower level. So usually in secondary side, we are going to have a lower voltage when compared with the input side. So usually the voltage for the secondary is not going to be on 150 volt. So that I am taking the terminal from the 150 volt. But even you can take it from 300 volt, that is nothing wrong. Since the voltage is going to be within 150 level, so I am taking the range of 150 volt. So from this 150 volt, I am connecting this 150 volt to secondary winding S2 terminal. Okay, so we just connected this voltmeter across the secondary winding, right? So we have connected 150 volt terminal to the S2 terminal. Okay, now we will see how to connect the other components. Next, I am going to connect wattmeter. So now for wattmeter, I am going to connect voltmeter common to wattmeter M. So voltmeter common point to wattmeter M point. So this is what voltmeter common terminal. From this, I am connecting to wattmeter M terminal. You can see it's connected to wattmeter M terminal, right? And then wattmeter L terminal, I am connecting to ammeter common terminal. You see this is a L, wattmeter L, which is connected to ammeter common terminal. Okay, this is ammeter common terminal we are connecting. Okay, and then I'll connect ammeter range terminal to electrical load, that is resistive load phase terminal. So you see again I having two ranges, 10 ampere and then 20 ampere. Based on my load level, my current is not going to exceed 10 ampere, so I'll keep on to 10 ampere range. But if you want to take from 20 ampere, that is nothing wrong, you can take from 20 ampere also. So I am taking from 10 ampere. That 10 ampere terminal connected to the resistive load phase terminal. Okay, right? You see now 10 ampere we are connected to resistive load phase terminal. Now resistive load neutral needs to be connected to wattmeter common and also either voltmeter 150 volt or secondary winding S2 terminal. Okay, let's do this connection now. So resistive load neutral connected to, see, wattmeter common terminal, right? And then this wattmeter, we are connected neutral to wattmeter common, and then this wattmeter common I am going to connect to 150 volt again. So wattmeter common, this red color wire connected to voltmeter 150 volt range. So this makes secondary side complete connection. Now we will see how we are going to perform the experiment. So this is what the table where we are going to mark all our experimental data. So by doing this experiment, you need to measure the primary side voltage and then primary side power, which is equivalent to input power, then secondary side voltage, then secondary side power, secondary side current, and then secondary side power. So the secondary side power is like output power, and then with this data we have to get efficiency and regulation. Okay, now let's get into how to perform the experiment. Before you start the experiment, ensure that your auto transformer is in minimum position. So once you switch on, now we need to give standard input voltage to the transformer, and we all know that we are performing the experiment with a single phase transformer. The single phase voltage level will be 230. So I need to gradually adjust this auto transformer to give 230 volt to the primary of the transformer. So let's slowly increase this, and the meanwhile you just check the voltmeter reading. You can see that the moment I am changing the auto transformer points, you can see the voltage getting increases. See, we are here connected to the 300 volt range. So which means whatever the reading I am seeing here has to be multiplied by 2. So if I want to keep 230 volt, I have to set here exactly at 115 volt, that is 115 volt. Now it is equivalent to 230 volt. So we are given a standard 230 volt. And I am not switched on any load. This condition we call no load. Now under this condition we need to record all the data. So now my input voltage is 115 into 2, which is a 230 volt. You can see this input side power is 0 watts. There is no power. And let's measure secondary side voltage. Now let's see the secondary side voltage, which is around 123 volt. Then let's see the secondary side current, which is again a 0 ampere. Now let's see secondary side power, which also still 0. Okay. Now if I calculate efficiency for this case, you see output power by input power, which is 0 by 0, I'll get efficiency 0. And regulation also, it is nothing but voltage at no load minus voltage at load divided by voltage at no load into 100. This is a formula. And you see now the nodal voltage on secondary side is 123, and we are not adding any load. So in that case, you can consider the regulation as 0. Right? Now what we do, we'll keep on adding some electrical load, and for each time I'm going to record the reading, and then I will try to figure out the efficiency and regulation. Let's switch on certain load over here. So first you turn on the main load, then I'm adding 0.5 kilowatt and 0.5 kilowatt resistive load initially. Now let us try to record the primary side data and secondary side data. Now let's try to record the primary side data. You can see primary voltage is still same 230 volt, that is 115 into 2. And the secondary side power, you can see it is around 750, 60, 75, around 75 watts. Now we try to see secondary side data. Now you can see the secondary side voltage around 121 volt. So let us record the secondary side voltage is 121 volt, and then secondary side current, which is almost 2.5 ampere, and secondary side power, which is almost 140 watts. Right, now with that data we need to get efficiency regulation, and before that I hope you all know that we need to find out the multiplication factor for each wattmeter, and that should be multiplied with the corresponding wattmeter reading. So let's look the MF for the secondary side wattmeter. You see in secondary side we have connected the voltage level of 150, right, and then you see here B1, E2 and B2, E1 is connected. So for this case, for a 150 volt, when B1, E2, B2, E1 are connected, the current rating is 10 ampere. So for 150 volt, 10 ampere, the multiplication factor is 2. So I need to multiply what are the reading I have recorded here by 2. So now my data will be 140 into 2, which is around 280 watts. Okay, similarly we look the same for primary side. In the primary side, you see we took the voltage range of 300 volt, and for that you see it is again connected same manner. So current is at 10 ampere, whereas voltage is 300 volt. Now for 300 volt 10 ampere, 300 volt 10 ampere, the multiplication factor is 4. So whatever the reading shown by this meter has to be multiplied by 4. So I have to multiply this by 4. Okay, now 75 into 4, we will get around 300 watts. Right, so now we can find out efficiency by using output power by input power. What is output power? Which is 280 divided by what is input power, which is 300 into 100 will give efficiency in terms of percentage. And similarly for regulation, what is no load voltage? No load voltage is this 123 minus, now what is the load voltage, which is actually 121. After we add a load, secondary side we see there is a small voltage drop. So that is 121 divided by what is no load voltage, same 123 into 100. So you calculate, this will give a voltage regulation. So in the same way you repeat the same thing by adding few more loads. Say example, you switch on 2 more loads, record all the datas and find out again the efficiency and regulation. So do the same thing for 3 more load. After you do, you need to draw the performance graph by taking x-axis output power in terms of watts, which is this data. Y-axis we take efficiency, okay, efficiency data, and you should record now for each reading what is output power. For example, in the first case output power is 0, efficiency also 0, so you need to start from origin. Then second case you see your efficiencies come around 90, above 90, whereas your output power come around 280 watts. So let's say it's 280, say your efficiency comes like here, and then likewise you need to record output power versus efficiency points over here, and you make a plot. So if you make a plot, a typical output power versus efficiency graph for a single phase transformer will looks like this. Okay, now based on the graph you try to figure out what you can infer.